Adam, sorry I'm late for this.
Hi.
Hi. Hey, how's it going? All right, we don't have too much on the agenda today. We had this call last week, so maybe that's why. Maybe we can start with a question about add column with default. So recently we added a Rubocop that basically complains when you use it without allowing null values, and that's also the default. So that's rather unfortunate. Rubocop basically complains about most of these calls. The reason for that was that we don't want to, or you can run into an issue with that when you don't allow the null values, because then you have to validate that there are none. And that means scanning the whole table once. And for large tables, that may actually be a problem, because scanning a really large table can take a long time, basically. And while you do that, you hold the lock, and that's maybe a problem. That all goes away with PG, with Postgres 11. We want to support that from GitLab 13. But until then, the COP is mainly there to basically trigger a discussion about it. And in some cases, it may still be acceptable. I think this is really a problem for the large tables. What I would suggest to do is test how long it takes to scan the table in production. If that is maybe longer than 10 seconds, 15 seconds, and maybe a problem. Everything below that probably should be fine. And yeah, with Postgres 11, we can this totally goes away, because we can add columns with the default, and that's a no time operation basically, or it doesn't require scanning the whole table. Any comments about that, or should we move on to the slightly related lock timeout issue? Sounds like we're moving on. Adam, would you like to explain what you're doing on the MR?
Yeah, so in the recent releases, we had several cases when we tried to deploy to production and run the migrations. And for some reason, some of the migrations were basically failed with a statement timeout. So the main reason was that the migration code that changes the database definition, like changing a table, adding a new column or foreign key, couldn't acquire a lock in time to actually execute this statement. And this is not the only problem. The other problem is while these statements are waiting to be executed, so basically waiting for a lock, other operations like reading up the table or updating the table might be also blocked because of this. And the result, just to summarize it, in some cases, we are not able to remove a table or drop a column depending on the table. So, for example, a high traffic table like products, it's really unlikely that we can actually add a new column or remove a foreign key definition. And my change is to, the idea came from Nikolai, I think, first. So to make our migrations short, so we try to execute the migrations in a loop several times with different timeout configurations, and we are hoping that playing with the lock timeout, the amount of time we are waiting for the lock, at some point we will succeed. And also, while we are waiting for the lock for a really short period of time, we are not going to affect the overall performance of the application. And I have a question about this actually. How does the lock timeout, so the time that we allow a statement to get a lock, and the statement timeout, really, are they counted together, or how would we define these log timeouts? Can they be larger than the statement timeout, or should be always lower than the statement timeout?
I think they should be, so the log timeout should be lower than the statement timeout. The reason is that basically the statement timeout is the time after a query gets canceled from the very beginning. So when you submit the query, and when that takes longer than 15 seconds statement timeout, then it gets canceled. That doesn't depend on any state of the query. So it can be locked for that amount of time. It can be scanning a lot of data, and then it just gets canceled. And the lock timeout is basically a subset of that, where only if it doesn't start or it doesn't execute because it's still waiting for a lock for this period of time, then it gets canceled after lock timeout. That is always for the length of the query. Obviously, that's always shorter than the total time for the query. So I think a lock timeout that is greater than a statement timeout doesn't make sense because of that. And having that shorter makes a lot of sense.
But we should also calculate, so our statement timeout is currently 15 seconds, as far as I know. So the log timeout should be less, and we should also kind of calculate that, hey, the statement actually needs to be able to execute. So that leaves us, I don't know, like 50% of the time we can wait for the log, or do we have any statistics about it? How long a DDL statement takes? Not really. Because
that's a good question.
It can always change depending on the table size.
Yes, and also for some migration helpers, we explicitly disable the statement timeout, because otherwise we wouldn't have a chance of doing that at all. So I think in context of the of implementing that retry mechanic, I think you don't have to worry about the statement taking or the statement timeout at all, because if it runs into the statement timeout today, then that's the same. It works the same way with the retry, just that we limit the amount it can be in this waiting for a lock state, right?
Okay. Yeah, that makes sense to me. I was just not quite sure how they relate to each other, but now it's a bit clearer. Thanks.
I'm very curious about how these numbers are going to play out. I saw you now explicitly define basically how long we wait initially for the lock timeout, and then we increase that, and also increase the sleep times. I think is a very good approach because it's so explicit. Like you're explicitly defining what happens in each step.
Yeah, I was thinking, some kind of function to calculate it, but if you want to customize it, you have to understand first that function. And if you did something really special, we would probably use different timings if we use this piece of code, because you can actually use it in the application code, right? Nothing stops you to use it outside of the context of migrations. We have high volume updates on tables, so we could easily have these kinds of functionality there as well. But yeah, the main idea is that, hey, just provide us an array with the numbers you want to run with, and then we just use them.
Mm-hmm. And it could very well turn out that in the future we have more experience with that, and we see that, oh, this is an exponential backoff is something that we typically want, and we can still implement that. But it gives us the ability to easily change those numbers today. I think it's really good.
Yeah, and we log these, so I'm hoping that these logs will show up in Kibana, migration logs. I'm not really familiar about that, how we consume logs. But if we do consume the migrations.log file, then you can easily get some kind of data over time to actually figure out, hey, how long did it take to get a log on average? What are the good timings? And yeah, in the MR, the numbers I came up with, this huge array is just kind of like a guesstimation. I mean, I try to kind of handle the case when we have a really high traffic table with lots of reads and updates, and that's why we do a lot of a really short log timeouts at the beginning, and later on when you have a really long import that usually runs in a transaction and really locks the project's table and might be other tables locked also. That's why we have also longer sleep times, like around 10 minutes. Yeah.
It's really hard to tell what numbers we should put there, right? Without any further experience. So this is also where we can iterate on and see how it goes and then align those numbers. And as far as I could see, the sort of the fallback from when all those retries with low lock or with actually a limited lock timeout failed, is that we really run it without a lock timeout, right? That's the last step after exceeding all those retries.
Yes.
And that's also interesting for I think for the delivery team in terms of deployments, is that we don't. By doing this, we don't risk that the migration blows up in the end because of it, but we try to improve the situation by starting with low lock timeouts, which sort of adds, which helps the stability of the site. And only when we exceed those retries, we do what we already do today. We run it without any lock timeouts. So it shouldn't blow up migrations because of that. It might take longer until the migration completes, though, obviously, because of those retries. Right.
Yep. But I think the first time we would just probably try that directly. Let's say remove some unused tables. I think 2 tables we can easily get rid of because they are not used. We can see how it goes with those 2 tables, and if we get enough, how to say, if we are confident that this actually helps, we could end up wrapping the whole migration with this piece of block, and it can be basically like transparent to the developers. They don't really have to know about it.
That would be really great to have. Yeah, I think it would work fine for migrations that are running within a transaction scope, right? Because you can easily retry that and it's consistent and all that. I wasn't so sure about how we could handle transactions that disable. Migrations that disable the transactions. For some of them, I mean, using the concurrent index helpers, for example, those can be retried as well, right? They check for existence first and then they create the index, so that's not a problem. But maybe there are some where retrying is a problem, where sometimes these migration helpers, they have multiple steps where maybe one of them hits the lock timeout, and then you retry and you actually start from a maybe inconsistent state. So not sure about how to do that.
Yeah, we can start with only introducing 2 migrations where we don't disable the DDR transactions, because those I would expect no problem there. But yeah, I know we have some helpers that do a bunch of steps, and they do their own transactions. So that probably needs more research how to deal with those.
On the other hand, I mean, those are the migration levels that we implemented, right? And we could also review them and say like, oh, this is this helper that has 4 steps, and one of them is prone to locking all the traffic out because it's an alter table. And then we explicitly wrap this step into the retry helper. And then you can still use it the same way. You disable transactions, you use the concurrent helper, but those individual steps that are risky are wrapped into that. Cool. Yeah, but really looking forward to seeing that. I think the risk that we have today is really quite a bit, because you run a migration and you run into that situation. You may lock out all the traffic for maybe even an extended period of time. It's really good to have that. Cool. Shall we move on to explain plans?
Yeah, fine by me. I just wanted to let you know I ran into the other link as an alternative to the explain.tespes.com. So maybe in cases where the one or the other is not working fine, you can consider one of the other. Just I didn't know about it. Apparently you did, Andreas. So I'm just spreading the knowledge, and hopefully it will help people out in the future.
It also has a nice fancy visualization, right? That the other one doesn't.
Yeah, maybe too fancy in some cases. So yeah, it's a trade-off.
Right.
Okay, and then I just added another item to the agenda. I'm not sure if you have documentation on background migrations. So for all migrations and database related stuff, we say we do everything in CE also. So everything what happens in EE also happens in CE. But there was a bit of a discussion about background migrations because there might be a lot of EE only code in the background migrations that is not needed to have in CE. So I put out a proposal where we, if you have a background migration that does EE only stuff, that you implement a normal background migration for CE code and build the EE features as a mix-in. So in a CE code base, there will be a perform method that does nothing, but in EE it's overridden and it will do the stuff that it needs to do for EE. I'm not sure if you have documentation on this already, and if I understood from the comments on the issue I linked, Valerie is already planning to document that. But a bit of back and forth, and I think we're on the same page. But we're he wanted to have more from the issue, but I think my intentions were exactly the same as his were in the other one, in the other issue he linked.
And right now, when you downgrade from the Enterprise Edition, then and you have background migrations running, then they're just stuck retrying forever.
Yeah, that we've seen that happen. So when you install, so it might be that when you start a bunch of background migrations, they get scheduled in Sidekick, and then at some point you might have installed CE over the EE code base, and Sidekick tries to start those jobs, but it cannot load the class because it's no longer in the code base, and then it fails, and Sidekick decides to try again and try again, and yeah, we have customers complain about this. So.
Yeah, sounds like a good change. There is not more on this topic. I have an unrelated question. What is lobsters? You had it on the
Yeah, it's like Hacker News, but it's an alternative for Hacker News, but it does basically the same, and it's they have a bit different intentions. So they're not aiming to and to some people, Hacker News is really a showcase and to be fancy dancy about all the things that happen in the tech world, and they want a more I don't know how to say that. I should read their terms because they're not a big fan of Hacker News themselves, so they try to do it slightly different than Hacker News does.
And this is where you got the idea for Dalibo, or
the idea for what?
Sorry, for the other planner tool from Dalibo.
Yeah, I follow that account on Twitter, and I saw that pass by.
Ah, okay, I see. Thanks. Cool. Something else you would like to discuss, or any other topic?
just one thing, I've seen a discussion about this structure.sql thing. So switching from schema.rb to structure.sql. And I just want to know, is this something you are currently looking at, Andreas?
Kind of. We have it scheduled for the next milestone. So this is to move away from structure Ruby to the SQL schema dump. I have played around with this a couple of times, and the issue I ran into is, and I think this is what you're referring to, right? This the problem that we have different Postgres versions, and their schema dump is different, and then there's no compatibility. I haven't looked further into it, but I was planning to do so in the next milestone.
Okay. A side note, I was playing with it a bit, also on a dummy Res project, because I was just experimenting with table partitioning, and we need to find a way to reduce. So structure.sql, it's more verbose, right, than schema.rb. So the chances of merge conflicts, I would say, a bit higher than using schema.rb. And in some cases, when you use a special Postgres feature, so I was using partitioning, running migrations in test environment also basically dumped the schema of the partitions created in the test environment. Mm-hmm. So probably we need to find a way to somehow filter these out, so we always generate a consistent structure.sql file. Which brings me to another question. Did we consider actually staying with schema.rb and maybe look for a gem or an extension that enables us to do more advanced database stuff, but still staying in the Ruby world?
Mm-hmm. I haven't looked for that. I was sort of assuming that structure SQL is the way to go, but there's maybe a few things against that. Is there such a gem or something you can recommend?
Yeah. So there was one from Shri about these materialized views. There is a gem that helps creating materialized view, and there is also Active Record Postgres extensions. I will add it later to the document. I don't have it here right now, but that also enables native enums for Postgres.
Mm-hmm. When I thought of the structure SQL as a way to have a very universal kind of schema management where you can do everything, basically everything that Postgres supports. But yeah, I was also under the impression that it's very fiddly, because you may have different Postgres versions, different dump tools, and you mentioned the problem with the partitions. It's quite universal, but also maybe a bit fiddly. If we can get something else that's sort of that we can use for general purpose additions, so we would have, I don't know if we can do that, but maybe we can have the schema.rb, and then in addition to that, have an additional schema where we have the kind of more advanced features in there, so that we don't have to add gems for each and every feature that we want to use, so for enums, partitioning, and all that, but we maybe have something on the side in addition to the schema.rb. But yeah, yes. Definitely interesting. Thanks for that.
Yeah, I was thinking about some kind of separation, maybe to keep using schema.rb, but maybe on the side, when you want to do something really advanced that is not supported by Active Record, then you need to provide a pure SQL solution, and that will be also executed when you load the schema. Not sure how would that work. But I will try to find and link those gems that tries to basically extend the current functionality of Active Record.
Mm-hmm. Thanks. I can just imagine that there is quite a few features that we want to use, and even just simple ones as using table constraints. For example, we discussed that for, I think, text columns and limiting the size of text columns. You can use a table constraint. Active Record doesn't support that, so we can't use it at the moment. Would be nice if we could be more like flexible on that end. Cool. Sounds like we're at the end of the topics, unless there's more. Which it doesn't sound like it. So thanks for the chat and have a nice day and talk to you soon.
Bye.
Bye, everyone.
Bye.